Now, moving on. So we got the idea of the size. We got one quantum number which is giving you the idea about the size. Let's move on to the next one, which has a peculiar name called the azimuthal quantum number, represented by the letter L, and this will give you idea about the shape. We'll see how, but the azimuthal quantum number gives an idea about the shape of the orbital in which the electron is being housed. Okay, absolutely simple concept. Okay, so we saw that there are four. We basically saw four kinds of orbitals. There can be more, but as of now, let's focus on these four orbitals. We saw that there are these orbitals, right? Now, we know that these will have different shapes. Okay, we'll just see those shapes. What are those shapes? But for now, let's designate the shapes of S the azimuthal quantum number of 0. Okay, let's designate the orbital p the azimuthal quantum number of 1. So any orbital which is p, like it can be 3p, 4p, whatever, if it is going p, and if I ask you what is the azimuthal quantum number of an electron that is going to an orbital 4p, the answer will be 1, because the azimuthal quantum number of any p orbital is 1. Okay, similarly 2 and 3 for d and f respectively. Okay, this is as simple as that. Now, for here, the electron, which was this electron, I asked what is the principal quantum number of this. It was 3, because it was 3s, so n became 3, principal quantum number. Now tell me, what will be the azimuthal quantum number for this electron? The azimuthal quantum number will be 0, because it's in the s orbital, and the azimuthal quantum number of s orbital is given as 0. Okay, it's very simple. For p in here, the azimuthal quantum number will be 1. The principal quantum number will be 2, but the azimuthal quantum number will be 1. Similarly, if you have a d, like a 3d, so the azimuthal quantum number will become 2. For f, it will become 3. Okay. Now, there is this idea that the L max is basically the maximum L that can be reached is basically n minus 1. What does that mean? That means, say you have the principal quantum number of 3. That means for the principal quantum number of 3, L max can be 2. What are the different L's? 0, 1, 2, 3. For principal quantum number 3, you can only have an azimuthal quantum number of 0, 1, or 2. Okay? Now this comes out to be, so if you have 3, so you can have, so L max can go to 2. What is the L least? 0. So you can have a 3s. You can also have a 3p, because for p the L is 1. You can have a 3d, because the L max for 3 is 2 and L is 2 for d, right? But you cannot have a 3f. Why? Because for f, the L becomes 3. And what is the maximum number of L allowed for this principal quantum number? Is 2. You can have a 4f, but you cannot have a 3d. Similarly, you cannot have a 2d. You cannot have a 2d. Why? Because when n is 2, the L max becomes 1. And that is why you cannot have a 2d. Similarly, you cannot have a 1p. Same logic. Okay? So this is the concept of the azimuthal quantum number. But now I said that azimuthal quantum numbers gives the shape. Okay? Now let's talk about the shapes. Let's see what are the different shapes that are available, that are there. Okay. Now, the s orbital, the shape of the s orbital is spherical. Is something like, so if you have the x, y, and z axis, just for orientation, the shape is spherical. Okay? This shape of the s orbital is spherical. And this can be a hollow sphere, or it can be a fully compact sphere, like filled sphere. But it has to be spherical. The shape of S is spherical. The P, the shape is a dumbbell. How do you represent that? So if you have something like this, it looks like this. It's like if you have a balloon, like this, you pinch it in the middle, it forms two lobes, right? And there is like nothing in the middle, but it forms two lobes around that. So that is basically the shape of the p orbital. It's like a dumbbell shape, right? This thing is filled, right? This is a 3D figure. Okay, D, it says double dumbbell. So it forms something like so. So it is something like this. So there are two dumbbells like these. Okay, the F orbital is really complicated, so I cannot draw that on the board. Okay, this has a complicated or a complex shape. Okay, so the L for these were 0, 1, 2, and 3. Okay, pretty simple concept. Okay,